Okay, so in this problem, they want us to write this in standard form. So we wanted to write in standard form as a plus bi. So we have 5 minus I divided by 4 plus I. And the goal here is to eliminate or get rid of the I in the denominator. Denominator. Okay? So we have an I in the denominator, so we need to get rid of that. And in order to do that, um, we need to multiply by the conjugate. Okay? So the conjugate comes from the difference of squares. Okay? So it comes from the difference of squares. Okay? So that's our goal. We need to multiply by that. And the difference of squares, remember, is the a squared minus b squared, which is equal to a minus b times a plus b. So for example, if I had, x minus 3, the conjugate would be x plus 3. And vice versa, if I had x plus 3, the conjugate would be x minus 3. It's always the opposite. Okay? So in this case, um, we focus on the denominator. We want to get rid of the I. So that means we need to multiply by the conjugate. So the conjugate in this case is 4 minus I. Remember that, okay? So we have 4 minus I in the denominator. And whatever we do on the top, the bottom, we must also do on the top. All right, so it's like multiplying by 1. So we haven't changed anything because this is still equal if I were to rewrite this 5 minus I divided by 4 plus I. Okay? All right, so but if I don't do it on the top and the bottom, that means I've changed the problem. So again, that's important. And again, you want to focus. This is a positive. You want the opposite to be negative. Remember that. Okay? All right, so now I like to just write my scratch work on the bottom. And so just focus on each part. So I have the 5 minus I times that by 4 minus I. Then I have the 4 plus I multiplied by the 4 minus I. Okay. And then I just, use FOIL or whatever method that works for you that you can multiply this out. I just like taking that first number and then multiplying by 4 minus I. So it's like basically like FOIL. I take that number and multiply those to two of these terms. And then I take the second number minus I and then multiply by the same factor again. So take that number here, multiply by that term and that term. That's how I do it. It's the same thing as FOIL. Okay. But if you like writing FOIL out, FOIL, please do that. So now I'm going to distribute this. So I'm going to multiply each one of these. Okay, so I'm going to multiply this by 5, multiply this by I. So I'm going to get 20 minus 5I minus 4I, and then negative gives me a positive I square. Well, remember, I square is the same thing as negative 1, right? And then I combine these guys. So that's going to be negative 5I minus 4I, which is negative 9I. And I still got the 20 I need to bring down. Okay. And then I combine my like terms. So I have a 20 here and a minus 1 here. So that's going to give me 19. Okay. Again, I'm matching these guys here. And I still have the minus 9I left over. All right. So that's what's going to go on the top. So I'm going to have 19 minus 9i. Okay. All right. Now for the second part here, the 4 plus I times 4 minus I can do exactly the same thing. I can FOIL this out. But I have, as I mentioned, this is basically the difference of squares. Okay. We got the 4 minus I and the 4 plus I. So I'm just going to use this formula. Again, if you don't feel comfortable doing that, please do the FOIL method. But I like to just, since the formula's there, why not just use it? So I have, this is my A, this is my B, this is my A, and this is my B. So that's A minus B, A plus B. And that equals, all right, and that equals A squared minus B squared. So A is going to be 4, and that'll be 4 squared, and B is my I, so that'll be I squared. So 4 squared is 16, and I squared is -1, right? So two negatives will make a positive, so that'll be 16 plus 1, which gives me 17. Okay? So that's what's going to go on the bottom there. Okay? So I can leave my answer in this format. That's fine. Or if we want to break it down to, say, 19 over 17 minus 9 over 17i, that's fine too. But both of these answers here are acceptable. Okay, so this is a rational equation involving inequalities. So in the rational, with the rational equation, okay, we want to focus on denominators. Okay, all right. So it's going to be easier if we get rid of the denominators. In order to get rid of the denominators, we multiply by the least common denominator, which is the LCD. So in this case, my LCD will be 8. That'll be the least one. I can also pick 16 if I multiply 2 times 8. That's another way. But again, we want the least one. So which term is going to go evenly to the least one? And that would be 8. Okay? Or which factor? So I'm going to multiply. Here's a different color here. I'm going to multiply um, the first term here. So the key part here is, I'll put a big star here, multiply the LCD to each term. Okay. I see a lot that students don't multiply everything by the LCD. They'll just focus, say, on the right side, and they forget the left, or they'll focus on the left side, and they forget the right. So make sure that we have 3 terms, so that means I need to multiply this 3 times. So I multiply this by 8, I multiply this by 8, and I multiply this by 8. Okay? 3 times, because we have 3 terms. And then I'm just going to simplify this. So I know 2 goes into 2 one time, right? And then 2 goes into 8 4 times. So that means I have 4 times x on the left side. I still got the inequality. Then I have 1 times 8, which is just 8. And then the 8's here, they go away. This 8 here will cancel with this 8 here. So that means I only have the x left over. Okay? And then I combine like terms. So I'm going to add x on both sides. So this x here is gone, and I have 5x is greater than or equal to 8. Okay? And then I'm going to divide by 8. So that gives me x is greater than or equal to 8 fives. So I want to show you 3 different ways to write your solution, because it's going to ask you this. So this is one way, right? If we were to write this in interval notation, we would have a bracket, 8 fifths to infinity, right? Because any number bigger or equal to 8 fifths is a solution. Or if we were to draw this, again, if we were to draw this solution, it's a straight line, right? I don't mean like a linear line. That's not what we want. And I see that a lot. We want just the number line here. And I always put, the number that I'm focusing on in the middle. Okay. And maybe numbers to the left and right of that. Okay. So uh, maybe 10 over 5 here and maybe 6 over 5 over here. Okay. And I look at my arrow or my inequality and it says it's going to the right. So I'm going to focus on 8/5 and it's greater than or equal to, so that means it's going to be filled in. And my arrow or my inequality indicates that I'm going to the right, so I'm going to put my arrow to the right. And that only works when the x variable is on the left side. Okay? So again, three different ways to show your solution. All right, so in this problem, again, we want to solve this rational equation, and we have 5 over x minus 4 equals negative 6 over x plus 6 plus 28 over x minus 4 times x plus 6. So again, in the rational equation, we focus on the denominator, and we want to get rid of the denominator, and that's the easiest way to solve these problems. So we focus on the denominator. In this case, we want the LCD. So the LCD in this case, the least common denominator, are going to be these two factors, the x minus 4 and x plus 6. Okay, so that means then I need to multiply each of these terms by the LCD. Okay, if you have a hard time figuring out what the LCD is, just multiply the denominators. Okay, that's one of the easiest way to do it. Sometimes you have to do a little bit more work because you didn't find the least common denominator, but eventually you'll get the solution. So I'm going to multiply this by x minus 4, x plus 6, x minus 4, x plus 6, x minus 4, x plus 6. Okay. And then I'm going to start canceling out my terms. So x minus 4 goes away. So I'm left with 5 times x plus 6 on the left. The x plus 6 goes away, so I'm left with 6 times x minus 4. The x minus 4 goes away, as well as the x plus 6 goes away, so I'm left with 28. Okay, and then I just distribute. So I distribute the 5, so that will be 5x plus 30. Distribute the 6, that will give me negative 6x plus 24 plus 20. And then I combine my like terms. Okay, so sorry, that's the 28 right there. Not 20, 28. Okay, so what do we get here? 24 and 28. So we got minus 6x plus 4, 52 on the right side, right? 24 plus 28 gives me 52. And then I have 5x plus 30 on the left. So I'm going to add 6x on both sides. And then I'm going to subtract 30 on both sides. You can do more than one operation at a time. So, but again, if it's too complicated, just do it one operation at a time. So my 30 and minus 30 are canceled. And then I have 5x plus 6x is going to give me 11x. And then my minus 6x and my 6x are canceled. And then 52 minus 30 is going to give me 22. Then I divide both sides by 11. Okay. And that gives us 2. All right. Now, one thing you want to do with rational equations is you want to plug it back in because sometimes it's not going to work. So, particularly in the denominator, that's what we're focusing on. So, it's just a reminder for these types is to plug um, um, x back in the original problem to see if we have a solution or not. Okay, so if I plug 2 back into the original, right, again, I'm just focusing on the denominator because that's where I'm going to have issues. I have x minus 4. 2 minus 4 is negative 2, so that's okay. I have x plus 6. 2 plus 6 is 8, is okay. So that means that the denominator is never going to be 0. So that means then my solution for this rational equation is going to be x equals 2. So for this problem, we're going to solve for t. We have the problem g is equal to c over 1 minus t. Method, I'm going to show two ways to solve this problem. Okay. The first way is what we've been doing. So this is another, it doesn't seem like it, but it is a rational equation. It's in fraction form. So we have g equals c over 1 minus t. So that means then I need to focus on the denominator. So the denominator in this case is my 1 minus t. So I'm going to multiply both sides by 1 minus t, just like we have been doing. So multiply this by 1 minus t, multiply this by 1 minus t. Okay? So the left side here is going to give us g times 1 minus t, and then the right side here is going to go away, which leaves us with just c. Okay? Then I'm going to distribute. So I'm going to distribute the g here because I'm trying to get t by itself. So g times 1 is g, and g times t is minus gt equals c. Now, I can make this really complicated because I have a negative here, or I can make it the not so complicated. I want to do the least work or least steps. So I'm actually going to swing the minus gt to the right and move the c to the left. So again, I'm going to add gt. I'll do step by step. Okay. So that gives us g is equal to c plus gt. Then I don't have any negatives anymore. Then I'm going to subtract c on both sides. That gives me g minus c equals gt. Okay? Then my last step is just divide by g. And then there's our solution right there. Okay? So t is equal to g minus c over g. Now, you can write this so you might have kind of a different alternative to this solution. What I mean is, or variation how it's written. We can write it this way. This is acceptable. Or you can write it as g over g minus c over g. That's the same thing. Or we can write it as g divided by g is 1, isn't it? G divided by g is 1, so we can do 1 minus c over g. So again, you might have a variation of your solution and it's still acceptable. So again, all three of these, okay, are correct, right? So that's method 1. So let's go ahead and do method 2. Okay, so I have the g equals c over 1 minus t. Another way to rewrite this is writing it in proportion. So proportion just means two fractions that are equal to each other. So for example, we have 1/2 equals 5 over 10, right? Those are two fractions that are equal to each other. That's what I mean by proportion. So what I can do is the g The G I can rewrite as G over 1 because G divided by 1 is the same thing as G. So I can rewrite this as, let's use this one here. I can write this as G over 1 on the left side. Okay. Then I can cross multiply, right? With fractions, I mean, with proportions, you can cross multiply. So I can multiply these guys together, or, and then I can multiply these guys together, right? I called it the butterfly move. Okay. So that leaves us with G times 1 minus T equals C. Okay. And the rest is the same way as we did on the left side for method 1. We go through the same format. The only difference between method 1 and method 2 is how you approach the first step. So, so in this case, what I did here is just rewrote G as G over 1, and then I cross multiplied using the butterfly move, and then the rest is going to be the same as this. Okay. So again, two different methods or two different approaches of solving the same problem. All right, so we want to solve this problem by the square root method, and we have the problem 4y plus 8 in parentheses square equals 64. So let's solve it by the square root method. So we have a power of 2, so in order to get rid of this square, we need to take the square root. So take the square root of this side and take the square root on the right side. Okay, so then the square root and the power are canceled. And so that leaves us with 4y plus 8 and then square root of 64. Now we need to be careful. We know that the square root of 64 is 8, but since we're dealing it with an equation and it has a power of 2, now we have to also address the other possible solution, which is the negative 8. Because again, 8 times 8 is 64, and negative 8 times negative 8 is also 64. So we need to address both of the equations. So remember that. So this is going to be plus minus 8, not just 8, but plus and minus 8. So I would put a star there to help you remember you need to have two equations. So note, need to have two equations. Okay. Because now we're dealing with the square. So I'm going to have 4y plus 8. 4y plus 8 equals negative 8. And then 4y plus 8 equals positive 8. So again, I need to have two equations. And then we just solve. So we have minus 8 minus 8. That gives us 4y equals negative 16. Divide both sides by 4. And that leaves us with y is equal to negative 4. Then I do the same thing on the right side. I have minus 8 minus 8. These 8's go away. We get 4y equals 8 minus 8 is 0. Then divide both sides by 4. And we get y is equal to 0 because 0 divided by any number besides infinity is going to, is going to give us 0. Okay? Infinity is a kind of a tricky subject. So, but anyway, that's what we get there. All right. And again, it's dealing with these rational um, or radical equations. So um, you want to plug it in to make sure it does work as well. Okay. So in this case, both of them do work. So this one works and this one works. Okay, so for example, I plug in 0 in for y, I get 4 times 0, which is 0, and 0 plus 8 is 8, and then I take the square of that. 8 times 8 is 64. So that works. Okay, so in this case, they want us to solve this problem by factoring, and so we're going to use the slide method, sometimes called the illegal move. So again, we're going to use the slide method to solve this. So the first step here is to take that 2 and multiply it to the back. That's your first step. Okay, so we're going to have x squared minus 13x minus 14 equals 0. All right, so what we did was just take 2 and we multiply by 7, and that gave us our 14. All right, now what we want to do now is find factors. So I have my center. Maybe write it over here. I got my center plus and my last times. So my center number is negative 13. My last number is negative 14. So that's what the C and the L stand for. C is for the center number, which is negative 13, and L is the last number, which is negative 14. And then I need to find factors, right, of 14 that will give me negative 13 and negative 14. So the factors of 14 are 1 and 14 and 2 and 7. Okay. And I have to also address the positive, negative, positive, negative, positive, negative, positive, negative. All right. So those combination. So in this case, it looks like I need a minus 14 and a 1. So let's see. Minus 14 Minus 14 plus 1 gives me negative 13. So that checks. And then negative 14 times 1 gives me negative 14. So that also checks out. Okay? So both of this will work. So now I know my two factors. So I'll have x minus 14 and then x plus 1 equals 0. Now, be very cautious, and I'll put a star next to this. A lot of students will stop here and they're like, oh, I found my factors and I'm good. No, we need to continue forward, okay? Since we multiply by 2, then we need to divide by 2, right? So I'll write here a note, since we multiplied by 2, we need to divide by 2. All right, so whatever you multiply by, if we had multiplied by 3, then we divide by 3. If we multiply by 4, we divide by 4. But since we multiplied by 2, we need to divide by 2. So we're just going to divide the numbers, not the ones with variables in it, by that, what we multiplied by. So in this case, I'm going to divide this by 2, and then divide this by 2, and then reduce, and then reduce. Okay. So 14 divided by 2 is going to be 7. So that's going to be x minus 7. And then 1/2, I can't reduce that any further. So I'm going to bring that 2 and push it to the front. So that's going to be 2x plus 1. I think I showed you a video where it says bottoms up. Okay. So anyway, I just put that 2 in front of that x. And then that equals 0. So those are my factors. Okay. So if they said, factor this, you'll be done. But they want us to solve. So that means then we need to equal these factors to 0. Okay? So in this case, we'll have x equals 0 because we're going to add 7 on both sides. In this case, we're going to have minus 1, minus 1, 2x equals negative 1, and divide both sides by 2. So x gives me negative 1/2. So again, I just added 7 on both sides there. Okay, so those are our answers there. So we have x equals 7 and x equals negative 1/2. All right, so we want to solve this by completing the square. We have x squared plus 8x minus 9 equals 0. And there are two particular tools we need for this. Okay. So number one, we're going to need the formula or the tool b over 2 squared. We're going to use that formula in order to solve this. And the other one that we're going to use, the other tool we need to use is using the square root method. Okay, so those are the two things that we need in order to do completing the square. All right. And so remember, uh, this type of problem is quadratic. So ax squared plus bx plus c. Okay. And that in order to complete the square, the a has to be 1. The a has to be 1. If it's not 1, we cannot complete the square. So if we look at this case, we have 1x squared plus 8x minus 9. So we're good, okay? A is 1, perfect. If it's not 1, then we just divide by that coefficient. So for example, if it was 2x squared, you know, then we divide it by 2 to make it as 1x squared. So we divide every term by that number, okay? So um, we don't have anything bigger than 1, so we're good. All right, so again, you need to make sure that the leading term is 1. So that's one thing we need to address. All right, so the first step here is we want to bring the c over to the right. So we're going to add 9 to both sides. Okay, so that gives us x squared plus 8x equals 9. Okay, and then what we want to do is we want to add our boxes. So I'm going to add a box here, and I'm going to add a box here. It's kind of like a scale, right? What I put on one side of the scale has to match to the other side of the scale in order to balance them out. So what goes in that box? Well, it's going to be this formula, the b over 2 square. That's what goes in that box. So in this case, our b, right? So if we were to write this out, a is 1, 8 is b, and c is negative 9. So in this case, our b is 8. So that's going to be 8 over 2 squared. Um, Ignore this thing here. That looks like a negative, but it's not. I was just emphasizing those particular tools. So that's going to give us 4 over, let me rewrite that. That's 4 square, and then that will give us 16. Okay. So in this case, I'm going to put 16 on both sides. So 16 will go on the left, and then 16 will go on the right. So 16 goes here, and then 16 goes in there. Okay. All right, and then we're going to simplify. So we have x squared plus 8x, 16, and this gives me 25 on the right. Okay. All right. Then our next step is we need to factor, right? Now, if we get stuck on what to factor, we just look at our formula here. So remember, whatever our answer is, the step before it will always tell us what our factors are. So in this case, our factor is that 4. So we're going to have x plus 4 times x plus 4. Okay, so again, in any case you doubt what your factor is going to be, all right, you just look at your formula and see right before you answer it, the solution, what is that number? Okay, so we have 25, and this leads us to the square root method, okay? Because this is going to give us two factors that we can rewrite as x plus 4 square equals 25. And then we're going to use the square root method, which is take the square root on both sides. So that's going to give us x plus 4 because the radical and the square cancel. And then we have 25 on the right side. Okay. So we're going to have two equations. We're going to have x plus 4 equals 25, and then x plus 4, sorry, let me backtrack here, getting ahead of myself. Okay, so the square root of 25 is 5. Okay, but again, we have to address both of them. So plus and minus 5. Okay, so let me write it here now. X plus 4 equals -5, and then x plus 4 equals +5. Okay, so we're going to subtract 4 on both sides here. We'll get x equals -9. Subtract 4 on both sides here, we get x equals 1. All right, so those are our solutions there. All right, so in this particular problem, we need to understand that y, okay, another way to write y is f of x, okay? So they go hand in hand, they interchange the notation of this. So they can write as f of x equals something or y is equal to something. So just remember that these mean the same thing, all right? The other component is that if it's just, say, y is equal to 3, right? That can mean two things. It can mean it's a point on the graph, or it can be a horizontal line. Okay, horizontal line. If I had just say x equals, say, 4, again, same thing. It can be a point on the graph, or in this case, it can be a vertical line, right? So it just depends on the scenario you're working at, right? So just remember that. So is it talking about a particular point, or is it a vertical line I have to draw? Okay. So in this case, it says, how many times does the line y equals 2 intersect the graph? Well, remember, y equals 2 is either a point on the graph, or it also represents a horizontal line. So I look for 2. So this is 2, 4, 2, 4, 6. So 2 is right here. Okay. So there's this 2. And then it's a horizontal line, right? It says how many times does the line y equals 2. So I was talking about the horizontal line. So how many times does it cross the graph? So we just draw a horizontal line at 2 going all the way across. So we just find out how many times. So it crosses it once, twice, 3 times. So it crosses the graph 3 times. So we just write 3 times here. Okay. For B, we use a different color here. All right, so B says, for what values of x does f of x equals -8? So again, that's another way to write f of x equals -8 is y is equal to -8. Okay? Y is equal to -8. And we just address, again, that can mean a point or horizontal line. All right? So I'm going to draw another horizontal line here going across these two. Okay? So it's saying, all right, when y is -8, so I'm looking at this here and also looking at this point here. So when y is equal to -8, what's the x value? Well, it's going to be 1, right? This is the x value. That's 1. That's the x. And also here, when y is equal to -8, what's the x value? And that is -7. Okay? Let me show that. Okay? So again, we're focusing on these two particular points. Okay? So this is asking when y is equal to -8, what is the x value? Okay, so in this case, x is equal to -7 and 1. Okay, and the last part here is asking for what values of x is f of x greater than 0. So just kind of recap here. So remember, when f of x is less than 0 or less than equal to 0, that means we're looking at below the x-axis. Or I described it as somebody in the pool. So if it's less than 0, so that means they're swimming in the pool, under the pool, or I said in the pool, below the floor. All right. If f of x is greater than or equal to or greater than 0, that means we are above the x-axis, or they're above the pool. So again, this is below the pool and then above the pool. Okay. All right. And then if it was f of x is equal to 0, that means we're going right across the x-axis. We're on the floor, right? Right across. So it's on the x-axis. Okay. All right. So in this case, we want greater than 0. That means we want above the x-axis. So where is the guy above the x-axis? Okay. So let me erase these here. Okay. Right? So the guy is above the x-axis on this area here as well as this area here. Okay? So they're above in those areas. So when I describe this, I have to describe this in terms of x. So in this case, I'm starting at -6, so that's what it says here, -6, and I'm ending here at -2. Okay? All right, so for this part here, where f of x is greater than 0, that's going to be at -6 and -2. Now we need to be careful about our brackets and parentheses, our endpoints. So it just says greater than. So that means I don't want to include the endpoints. If it said greater than or equal to, then I would include the endpoints. Okay. So even though they're included here on the graph, it doesn't want it. Okay. So this is going to be just parenthesis and parenthesis. So again, that's where the guy is above the pool. Okay. And as well as we look on the right side here. So he's above the pool between 2 and 3. All right. So sometimes in the lab, it will have a union symbol and then 2 to 3. Okay. All right. So that's what that is saying. Okay. So since the 3 here is filled in, we should have actually a bracket there. Of course, it's not going to let me do it, but anyway, there should be a bracket there, okay? Because it's going to go from 2 to 3. So the endpoint we're just worried about is that 2 because it says greater than. If it said greater than or equal to, then we would include both the 2 and the 3. But in this case, we're not including the 2, okay? Because that's dealing with that greater than or equal to. But that 3 we must include. Okay. Okay, so in this problem, we're going to use the quadratic formula, which I have written here on the right, to solve this problem. Okay, so the first thing we need to do is we need to label these, right? So this is my A, this is my B, and then my C. Then we're going to plug in those values in there. So we're going to have B is -6. So we actually have a negative and then another negative. So be careful with that. And then we have b squared, which is again -6 squared, minus 4 times a, which is 9, times c, which is 1. Okay? All over 2 times 9. Okay? So what I like to do is I look in the radical first to see if I'm even going to get a solution, right? And then I do the rest. So it looks like I get um, -6 squared is going to be 36, right? So this is going to give us 36. And then 4 times 9 is 36, times 1 is 36. So it's going to give me -36 over here, okay? So this one goes there. That one goes there. So, um, 36 minus 36 is going to give us 0. Okay? And then the square root of 0 is just 0. So this whole right side here is just 0. All right? So negative negative is a positive, so I'll have 6 plus minus, and again, we get 0 in the radical. Divided by 2 times 9, which is 18. Okay? So again, the square root of 0 is just 0. So that means you'll have 6 plus minus 0. So that part is just eliminated. So because the square root of 0 is 0, so 6 plus 0 is 0, and 6 minus 0 is still 0. I mean, it's still 6. All right. So in this case, we'll have just 6 on the top over 18. Okay. And then we reduce. So 6 can go into 18 3 times. So that's going to be reduced to 1/3. Okay. So this is what they mean by um, so remember in quadratic, remember visually, that means you can either have these different scenarios. Oops. So either you'll have two possible solutions because it crosses the x-axis twice. You can have no solution because it doesn't. So this is 2. This is 0 solutions because it never crosses the x-axis. Remember, this is the x-axis here. Or it hits it at one point, and this is called one repeated solution. Okay, so it's basically saying that solution is repeated twice. Okay, so that's what that means. Okay, so in this case, this is, oops, this is a one repeated solution. All right, so in this case, what we want to do is we want to rewrite this. F of x equals -1 is the same thing as saying y is equal to -1. Okay, so we're going to replace f of x, which is going to be y, which is equal to -1. Okay, so we're going to have -1 is equal to 2x squared minus x minus 1. Okay, so it's normally, it will say, if x is equal to 3, what is the y value? All right. But now it's doing the opposite. It's asking if now y is equal to a number, what is going to be our x value? So it's just asking the opposite. All right. So in this case, y is -1, and then we need to find out what x is. And then we write it in this format. Okay. And then we just solve. So we're going to add 1 to both sides. And we have -1 plus 1 is 0. And then we have 2x squared minus x. All right. So notice that I have an x on both, on the 2x squared and then the x. So that means I can factor out an x. Okay. So that gives me x times 2x minus 1. And then I set them equal to 0. Okay. Why am I doing that? Because again, I have a power of 2. And that power of 2 tells me I should have two possible solutions. So if I try to move the negative x to the left and divide by x, I'm going to eliminate those solutions. So I'm saying if I move the other x to the other side, so I have x equals 2x squared, okay, I can do that, but if I try to divide both sides by x, I'm going to eliminate one of my solutions. So that's why I don't want to do that. Because again, I have a power of 2, that means I should have two possible solutions. So I want to factor when I get to this point. Then I can equal them to 0. Okay. Then I just add 1 on both sides here and then divide by 2. So x is going to give us 1/2, and then the other one is just going to be 0. Okay, so let's read this one more time. It says an open box is to be constructed from a square piece of sheet metal. So let's go ahead and draw that. So we have a square um, sheet metal. Okay. And it says, so we have a square piece of sheet metal. By removing a square of side of 4 feet from each corner. So that means then we are taking these corner pieces, right? And the corner pieces are 4 by 4. So this is 4 inches by, I'm sorry, 4 feet by 4 feet, 4 feet by 4 feet, so on and so forth. Okay. So that's what we know about this here. So we're cutting these little squares out of the corner. Okay. And says from each corner and then turning up the edges. So basically, we're going to form a box, right? So it's going to be an open box. So, okay. So we're going to have this open box. Now we need to figure out, um, are we doing volume? Are we doing area? Well, it says that the box is to hold 256 cubic feet. So that tells us that we need to work in volume. So to find the volume of the box, it's just going to be length times width times height, right? So length times width times height. Okay. And now we need to figure out, okay, what am I going to put in for these particular variables? So in order to do that, we need to look at our square piece of metal here. Okay. So we don't know the dimensions of this, right? We don't know. All we know that this is X by X. Okay. That's what we're trying to figure out. What's the dimensions of the sheet metal? That's what our goal is. Well, if we're cutting these guys out, right? So this is out, this is out, this is out, this is out. So that means then this portion here, let me use a different color here. Okay. So this portion here from here to here, right? That portion there, that's going to be what? Well, if I extend it here, right? But what's that going to be? Well, if I took up 4 piece here and a 4 piece on that side, so this, that's confusing. That little piece there, that's going to give me x minus 8. Okay? Because again, this is 4 on this side and then 4 on this side. So I'm taking 4 inches on or 4 feet on each side. So that means I'm left with the x, which is the total, minus 8 because I took out 2 on each side. That's going to be the same thing up here, correct? As well as over here on the left, as well as here on the bottom. All right. So when I write that or transfer that information here, okay, my length and width is going to be the same. So let me actually use the same color here. So I'm going to have x minus 8 and x minus 8. Okay. So these are just basically the bottom of the box. Okay. So that's the bottom of the box, which is that what we just discussed. That's the x minus 8. Okay. The bottom of the box is going to be the same as up here. Okay. All right. So this is our length and then width, and now we need to figure out our height. Well, remember we cut out the corners of that 4 by 4, so it means our height is going to be 4. Okay. So when you're dealing with this type of problem, just remember, since we are dealing with a square, both of the bottom is always going to be the same dimensions. And then the top, depending on how much you cut out, that's going to determine your height. Okay? So then we just transfer that information here in our volume equation. So we know that we have the length is x minus 8, the width is x minus 8, and then our height is going to be 4. And the volume, they already told us what that is, which is 256. So I'm going to write that right there. Okay. All right. And this is our goal. I'm going to put a star there. This is what we want. We want two factors to be the same. If we don't get that, that means we did something wrong. The output is 256, and then our height is 4. So you want at least 4 pieces of information here. Okay. And then now we can rewrite this. Okay, we can rewrite this because we have x minus 8. So we can rewrite this as x minus 8 squared times 4 equals 256. And then we can just solve for x. Okay, so then we're going to divide both sides by 4. Okay, and 256 divided by 4 is going to give us 64. And we have x minus 8 squared. Okay. And this leads us to one of the methods we have been learning, which is the square root method. So I take the square root on both sides. Again, I have a power of 2 that indicates that I should have 2 possible solutions. Okay? Again, I have a power of 2 that indicates we should have 2 possible solutions. So this is going to give me plus or minus 8. And then the square root and the power go away, giving us x minus 8. Okay, so again, we'll have 2 possible solutions. So let's write that out. So we have negative 8 equals x minus 8. And then we have positive 8 equals x minus 8. So we're going to have 8 on both sides. So that gives us 0 for x. And then we have 8 on both sides, add 8 on both sides. And this cancels. That gives us 16 equals x. So it's pretty obvious, right? One of them is not going to work, and the one with 0. Because if we plug in 0 in here for x minus 8, we're going to have a negative 8, which is a negative dimension. So we don't have that. That doesn't make any sense. So that means then our dimension has to deal with 16. So that means this is 16 by 16. So that's going to be our answer there. So 16 feet by 16 feet, because that's what they want. They just want the dimensions. Okay? The dimensions of the sheet metal is 16 by 16 feet. Okay, so when we have this type of problem and it's a power of 4, okay, what do we do here? Well, it's a trinomial. If it was 4 parts, then most likely we would do factor by grouping. But in this case, we only have 3 parts or 3 terms. So what do we do here? And it's a power of 4. There's a couple ways, but one way that we can solve this, and we use this a lot as we go into upper level math, is by using the U substitution. Okay? And we use that a lot in calc. Okay? So U substitution. So what do I substitute? Well, we want to rewrite this in a format or in a way that we know how to factor. So our goal here is to rewrite in a form so we know how to factor. Okay, so like I said, there's a couple of ways, but one way I'm trying to show you is the U substitution. I know there's other ways of solving this, but in particular, I'm just using the U substitution. Okay, so what do we do? Well, what we want to do is we want to focus in the center. Okay, particularly here at the x square. So we want to focus on the center term variables. Okay, and we have an x squared. So in this case, we have x squared. And that will let us know that's what we're going to substitute. So we're going to let u equal x squared. Okay. Now, before we do that, let's go ahead and rewrite this. So x4 I can rewrite as x squared square, right? Because a 2 times 2, our power raised to a power, is going to give us 4 if we multiply. So that gives us 4. And then here I have minus 26, again, x squared plus 25 equals 0. So I want to rewrite it in a way that I can substitute that x squared, okay? So now in this case, now I have everything in terms of x squared. Now I can just substitute that u. So x squared now is just u squared minus 26 u plus 25. So now I can solve this. Now I can factor this. This is something I know how to factor. All right. Um, so we have a minus positive combination that tells me that my factors should be negative. Both of my factors will always be negative. Again, if I have a minus here in the middle and the plus at the end, that means both factors have to be negative. So in this case, I'll have u minus 25 and then u minus 1 equals 0. Notice both of my factors are negative, negative 25, negative 1. Okay. Then I'm going to equal them to 0. So I have u minus 25 equals 0 and u minus 1 equals 0. Okay, and then I solve. So I'm going to add 25 on both sides. I get u equals 25. Add 1 on both sides. We get u is equal to 1. Now, we're not finished because we said u was x squared. So we're going to replace that u with x squared. So this is going to be x squared equals 25 and x squared equals 1. Then we take the square root. So I take the square root on this side. So that gives us plus or minus 5. Then I take the square root on this side, and that gives us plus or minus 1. So notice here we have 4 solutions, or 4 possible solutions. Okay. Um, but when we plug them in, we'll realize that each one is going to be a solution. Well, how do we know we have 4 solutions? Because of the power of 4 at the very beginning. So that tells me at the end, I should have 4 possible solutions. Now, some of them might not work because they're not real solutions. Maybe they're complex or imaginary, okay? And we don't want those. They just want the real ones, okay? In this case, all 4 of them work. So we'll have 4 solutions, which are positive minus 5 and positive and minus 1. Okay. So it says here a bank loaned out $12,000, part of it at the rate of 7% per year and the rest at 17% per year. If the interest received in 1 year totaled $1,500, how much was loaned at 7%? How much of the $12,000 did the bank loan out at 7%? Okay, so in this particular problem, the formula we're going to be using here is I is equal to PRT. All right, so P in this case, so I represents the interest, of course, right? This is the interest. P is talking about the principal or the money borrowed. Principal or money borrowed. R is the rate, and then T is time, and that's per year. Okay, annually. So that's what those variables mean. Okay, so we're going to use this formula to set this up. So we're talking about um, 2 things here, the 7% and the 17%. So let's write that down. We have 7% and then the 17%. Okay, and we also have the outcome, right? So what are we trying to produce? Okay, the outcome. So word problems, it's all about organization, okay? Organizing the information that they give you. Now, if I am focusing on the PRT, okay, again, so P is representing the principal or the amount borrowed. So in this case, the bank is loaning out $12,000. Okay, so that's what's being borrowed. I don't know how much is going to 7% or 17%, but I do know the total is $12,000. Okay, so um, so in this case, one of them needs to be X. Again, I don't know. So remember, we talked about a scenario where if I had $100 and I gave student A $40, what does student B get? Well, it's going to be 100 minus 40, which is $60. Total them together is the $100. It's the same thing here. So I'm giving or putting money, that P there, that's my X, that's my rate, right? So I'm going to have, I'll write it here, PRT, PRT. Okay. So P is X. I don't know. I don't know how much I'm putting in for 7%. But I do know for 17%, whatever is left over, I'm putting it in there. So in this case, or in this case, they're letting them borrow $12,000. So that will be 12,000 minus X. Okay. All right. So that's what P is representing. X for the 7%, and then the rest for the 17%, 12,000 minus X. The rate, right, for the 7%, we already know that is 7%. So this is going to be 0.07. And the rate for the 17% is going to be 0.17. And time is per year. So just one. So we're going to put one here and one here. Okay. So that's how you use that formula in this particular problem. Okay. And then our output is they want to get interest of 1,500 bucks. So that's the outcome, the output. All right. So then we're just going to add these guys and equal them to 1,500. Then solve. Okay. So in this case, 0.07 times 1 is 0.07. And 0.07 times x, that just gives us 0.07x. This one here is 0.17 times 1 is 0.17. So then I'm just going to distribute that to each of these terms. So 12,000 times 0.17 is 2040. And then we have minus 0.17x. And then we add those guys. And that equals 1,500. Okay. Then we're going to combine. All right. Some students mess up and they said, oh, it's minus 0.17, so I'm going to add 0.17. No, just combining like terms. So it's going to be 0.07x minus 0.17x, not plus 0.17x. If I was bringing it to the other side, then that's true. All right. So the 2040 stays the same. And then we're going to get 0.07 minus 0.17 is going to be negative 0.1x. And that's still equal to 1,500. Okay. Then we're going to subtract 2040 on both sides. We get negative 0.1 x equals 1,500 minus 2040 is going to give us a negative. Let's see, let me pause it for a second. Okay, so 1,500 minus 2040 is going to give us negative 540. Okay, and then we're going to divide both sides by negative 0.1. So when we do that, we should get $5,400. All right, now what does X represent? Well, X, we said, was the 7%. All right, and that's what they want. How much of the loan of the $12,000 did the bank loan out at 7%? So $5,400 at 7%. So that would be our answer there.